Hello and welcome back. This is the next video of the series Understanding Pointers in C. In this video, we are going to discuss why we require pointers in C programming. So there are quite a few reasons, so let's see those one by one. So the first reason is it helps us to manage the memory in a very efficient manner. Right? So the idea is when we are executing a C program, it might happen that on the go, that means while the program is running, we may need some extra memory. So we can demand that memory while the program is executing by using functions like malloc, calloc. So when we demand memory, we'll get memory, the memory will be allocated to us. So we need not name that memory, we can just have a pointer and we can store the address of that memory allocated to us by using a pointer, right? And later we can, if we don't want that memory, we can just use a function called as free, and to this free we'll pass the pointer which is pointing this memory, right? And this free function will free this memory. So this is how pointers helps us to manage the memory efficiently, dynamically, or on the fly, you can say. So for example, let's say this is how you get memory by using malloc. Here we are going to see this function in very malloc and this statement in very great detail later, but for now malloc will allocate this much memory, right? Let's say the memory required is size of the int. The size of will calculate the size of this integer data type. So let's say this is 4 bytes, so this will be 4. So this will be 4. So 4 bytes of memory will be reserved. Let's say these are 4 bytes. And in fact, this is called as typecasting of this memory. So the reserved memory, the allocated memory, has no type. We'll convert that no type means it's a void type memory, right? That means we can point a void type pointer to this memory, right? But we want to store an integer there, let's say. So we want to convert this memory into integer type. So that's why this is int star. So we converted this memory address into the integer memory address, integer type memory address. This typecasting does that. And then we have integer type pointer. So P is a pointer of integer type. So P is pointing to integer type of memory. Integer type of memory means the memory in which we can store integer data. So this can be done by using pointers. So then we can store the address of we have already stored the address of this memory in P. So in memory, this is pictorially I have shown. P is a pointer pointing this memory. In fact, what happens in memory is like P is storing memory address of this location. So 4000 is the starting bytes address, so that is getting stored here in P. So that is how pointers helps us to manage memory efficiently. That is one usage of pointers. The second usage of pointers is for function arguments. Now by default C is a call by value language. That means when you call a function and when we pass some arguments to that function, we are passing the arguments by value, right? So for example, let's say this is a swap function. It is accepting two arguments. These are called as formal parameters of this swap function, right? And let's say we are calling this swap function from main, right? So we have two variables here, x and y, in main function. So when we call this swap, we are passing x and y, but here we are passing the value of x and y, that is 10 and 20 will be passed. So this 10 will be passed to a, this a of swap, and this 20 will be passed to b, right? So 10 here, 20 here. So here we are passing the values of x and y when we are calling this swap function. What happens now here in swap, if I execute this swap, if I execute the code here, so temp, there is another variable called as temp. So temp will get a, value of a is 10 here, so temp will get 10. Then a is equal to b, or b's value is assigned to a, so b is 20, so 20 will be assigned here. And then b is equal to temp, so b is nothing but temp is 10. So this is in fact swapping two variables, swapping two values. We wanted to swap this original x and y, right? But what happened? A and B, which are copies of x and y, right? We have just copied value of x and y in A and B. They are changed. Original are intact. Original are intact. So this is the drawback of call by value. We are going to discuss this program in very great detail in the next coming videos. But for now, I just wanted to show you the uses of pointer, that is call by reference. So in brief, we'll discuss here, right? So call by reference, call by value, we are not able to change the original. Original are intact. Original are unchanged, right? So, but pointers, by using pointers, I can pass the references or the addresses, right? And thus I can go to the original and change the original. For example, let's say now our main is like this. We are calling the swap function. Now this is our swap, let's say, right? Swap is now not accepting the values, it is accepting the addresses, right? The parameters of swap, the formal parameters or arguments of swap are pointers now. Now A is integer type pointer, B is integer type pointers. That means A can store address of integer variable, B can store address of integer variable. Now when calling swap, I'll be passing address of x and address of y. I'm not passing this now. I'm not passing this. I'm passing this address, right? I'm not passing values. So and x, this address of x, and y, address of y. So this will be passed to A and B. Now A will hold address of x, that is 1000, and y's address will be copied in B, that is 2000 here, memory address, right? Okay, now let's execute this swap. Now A is pointing to x, B is pointing to y. In pictorially, if I show it like this, it will be A, this is A, this is B, right? Okay, so when I say temp is equal to star A, what is star A? This is dereference operator. This will give us value at address in A, right? What is address in A? 1000. What is value at 1000? X. So temp will get x's value, right? That is 10. So temp is equal to star A. Star A is the dereference operator. It gives us value at address in A. What is the address in A? 1000. What is the value at 1000 address? 10. So temp will get 10. Then star A is nothing but value at address in A is equal to value at address in B. What is the value at address in, so value at address in A, that is this address in A is 1000. So value at address in A is equal to value at address in B. What is the address in B? 2000. What is the value at 2000? 20. So 20 will be assigned to value at address in A, and that is 20 will be assigned here, right? Then value at address in B. Address in B is 2000. Value at 2000 address is temp now. What is temp? 10. Okay. 10. Now if you see what happened with this, we, because of pass by reference or call by reference, we are going to go to the original parameters, actual parameters, and are able to make changes over there, not in the copies like call by value. So pointers helps us to do that. That's one of the usage of pointers. So another use of pointer is efficient array and string handling. So let's see this example. Let's say in C, strings are nothing but array of characters, right? So this is how we store the string str equal to hello, right? So this str will look like this. The string is stored like this, and this /0 will indicate the end of the string, right? Then we are taking a pointer of character type which will point to this string, right? So this pointer ptr will point to the string. Now we are going to iterate over this array, which is the array of characters. Similar, in the same way, we can iterate over the array of integers, floats, etc. So we are going to start and we are going to loop through this till we reach the end of the string. So while ptr is not equal to /0, star ptr will give us value at address ptr. Ptr is holding the address of, right? With this, what will happen? If the starting address is 1000, ptr will hold 1000. Ptr will hold 1000, right? And star ptr will, this is how I'm just showing pictorially. This is just pictorial representation of this pointer, but actually in memory, the address is stored in this PTR variable. So while PTR is not equal to /0, star PTR is not equal to /0. What is star PTR? Star PTR is nothing but value at address in PTR. Address in PTR is 1000, value at 1000 is H. Is it equal to /0? No, it's not. Then we'll print that. Star PTR means value at address in PTR. That will give us H. Now I do PTR plus plus. So PTR was storing 1000. Now it will be, this is equal to PTR is equal to PTR plus 1. That means whatever address PTR is holding, that will be incremented by 1, right? So it was holding 1000. Now PTR will point to the next location of same type, right? So this is a character type location. So when I increment PTR pointer, it will point to the next character type location. So PTR will come here. PTR is incremented by 1, right? So here it was 1000. This will be 1001. 1001, right? So PTR equal to PTR plus 1. Now this is a pointer arithmetic, right? Here the address is not incremented by 1, right? It is not like 1000 plus 1, right? This is not 1000 plus 1. This was 1000, 1000 plus 1. It will not happen like that. What will happen is, if this is location of 1 byte, right? So when I do PTR plus 1, PTR will go to the next location, right? I'm going to the next location. I'm not incrementing the, I'm not adding 1 to this 1000. Now, just to understand this in another way, if this is a 2 byte location, if this is a 2 byte or let's say 4 byte location, 4 byte location like this, just to show you, if this was 1000 and there are 4 bytes here, right? So last byte will be 1003, let's say 1000 to 1003, 4 bytes, and PTR is pointing here. If you do PTR plus 1 now PTR will not go to 1001, right? It will go to 1004. That is next location, which is starting here at 1004, right? So this PTR is not, we are not adding 1 to 1000, but we are incrementing the location pointed by PTR by 1. This was actually 1 bytes, so it will automatically go to 1001. But if this location is of 4 bytes, so when I increment PTR, it will be incremented by 4 bytes. 1, 2, 3, 4. It will go to 5th byte, that is 1004 here, right? So that means now PTR will come here. This is pointer arithmetic. We'll discuss this in the next video in detail. Okay. So thus, in order to iterate over the arrays, we can use pointers. Pointers helps us to do that, right? So let's see another usage of pointer. Accessing the hardware and system level programming. As pointers give us direct access to memory locations, so this is very essential for embedded systems, operating systems, device drivers. So pointers gives us help us to do programming at that level, system level programming. Then building complex data structures like linked list, trees, and queues. Linked list we are going to discuss in later videos, but for now, if we see, linked list looks like this. These are called as nodes of the linked list. So these nodes are nothing but memory locations, and these memory locations are dynamically created. Now, in order to create dynamic memory nodes or nodes of the linked list, pointers help us, as we have seen in the first usage of memory, that is efficient memory management. By using malloc, we can demand memory dynamically and you can get it, and these nodes can be pointed by pointers, right? So and thus pointers helps us to create or build these kind of linked lists. Even trees have similar nodes, queues, stacks, right? So the complex data structures can be implemented or constructed by using the pointers. So these are some of the major uses of pointers in C. That's why we need to study pointers in C. So without studying pointers in C, study of C programming will not be complete, because pointers are the essential and integral part of C programming. So this is it for this video. See you in the next video. Thank you. Stay tuned.